All right, please, who can help us with some of the concepts that we came across yesterday? What do you remember from yesterday's session? Hi, Calvin.
Good morning, Akosia. Good morning, everybody.
Morning.
So yesterday we came across AWS Lambda, and we said it's a serverless compute service that allows you to run code without provisioning or managing servers. And also, you can create Lambda functions for a wide range of applications and back-end services, like API gateways, web application, mobile application, etc. Thank you.
All right, thank you, Calvin. So yeah, yesterday we looked at Lambda and we mentioned how it is used to run just your code. So Lambda is a serverless AWS is a serverless offering from AWS, and with Lambda, you do not need to provision any servers. You can just run your code, and you'd be able to get whatever compute function that you are looking for. So when it comes to the compute services that AWS offers, we have EC2, we have, okay, who can help me with the other two? So EC2,
Containers.
exactly. So EC2 provides virtual machines, and you can also have a container solution for your compute. And then lastly, you can have the serverless option for your compute. And Lambda is one of the, or Lambda is the serverless offering that AWS gives with regards to your compute needs on their platform. And so you're able to build and run your applications without provisioning or managing any service. And who remembers the maximum runtime for a Lambda function?
15 minutes.
All right, thank you, Perez. Okay, Yakubu.
Yeah, good morning.
Morning.
Apart from AWS Lambda, yesterday we saw APIs and we saw they were programmatic.
Hello, please can you hear me?
It helps.
Hello?
Yeah, whoever is speaking, we can hear you. Also, is that you?
Yes, please. I was
Okay,
talking earlier on, but it seems like you didn't hear me. Oh, it's fine. Thank you.
you're welcome. Yakubu, please continue.
Yeah, so we said API helps connect two systems together through programming. And then we saw a type of API called the REST API. Then we said the REST API helps to connect to computer systems securely using HTTP. And then lastly, we saw the components of REST APIs. And then we said it contains the client, the resource, the request, and the response. Thank you.
All right, thank you, Yakubu. So yeah, yesterday we mentioned that application programming interfaces, APIs, are used to provide our end users access to an application or to a server. Okay, so your end users would be able to retrieve some information or some function from your server thanks to this API. And apart from some tools or some components that can be used to retrieve this information to could also be applications. So I mentioned how sometimes your weather app already has information or already has some response for you, even when you haven't made the mini request, because the the way the app has been built or developed is that it retrieves some information from you from a server. So if one day you should go to that app and you're not able to retrieve that information, and it's likely that the API call must have failed. And we also looked at some of the error codes whenever an API call fails. We looked at the 4XX, which would usually mean that you don't have you haven't been authenticated properly, or you don't have the proper authorization to access whatever response that you sent your request about. So when it comes to APIs, we have the client, and then we have the request that the client makes to the server, and then the server is able or is not able. Well, the server always sends a response, so it could be a success response or a failure response. And when there's a failure response, you usually see a message body that would tell you the kind of error that you are experiencing. So thanks to APIs, we are able to retrieve some information from a server or from a system. And we also mentioned that the API is just like a middleman that comes to serve you whatever resource that you're looking for. So any resource you'll be looking for would have a universal resource identification. So that way you are able to send a request, and then that's that the API goes to bring you a response according to the request that you have sent. And the type of API we looked at is the REST API, and we also looked at some features of the REST API. Thank you, Yakubu. Ruben.
Yeah, good morning once again to everybody.
Good morning.
Yesterday, we also looked at the Amazon CloudFront. That is one of the Amazon services that is responsible of delivering content to the end users across regions. So with that, we also look at the concept, how this service deliver content to its end users. There we also learn about the location edge, the region, and the origin concepts. And we got to know that before it's a process, and the process is start from the origin. When the service is delivered, it must first of all get to the edge location. When the content is there for the end user to access, then there is no problem. But when there is no data in the edge location, then it must go back to the origin to retrieve the information from there and get back to the edge location before it get back to the end user. But when it doesn't go like that, that means it must first go to the origin, then bring the information back to the edge location. And that goes like a circle. Or if the information comes to the edge location for the first time, then the next time when the user wants to get the same information, it is easy to get it from the edge location without navigating to the origin. That is what I also learned from. Thank you.
All right, Ruben, that's excellent. We looked at CloudFront, it's AWS's content delivery network service, and it makes use of edge locations. So we know about the usual regions, availability zones, and then we know availability zones have data centers, but an additional infrastructure that AWS has apart from these regions is the points of presence or edge locations. And these edge locations are much more as compared to the number of regions or even the number of availability zones. Okay, so what's this these edge locations help with. They are also just like data centers, but then they've been optimized. So their specifications of those servers inside those data centers have been optimized for fast network performance. So it's the way you can make your servers web servers or database servers. These servers are the servers in these data centers are networking servers. So the specifications that they have been programmed to optimize networking and then data transfer. So these many edge locations all around the world, they help to deliver content faster to users. So instead of the user getting whatever content they're looking for, Daniela, sorry. Let me mute him from here. Okay, thank you. So so these edge locations, whenever a user makes a request for content from CloudFront, it goes straight to an edge location, goes to the closest edge location to the user. If the content is found in the edge location, then it's immediately served to the user very quickly. And if it is not, then the edge location has to request for it from the region or the origin. So the origin could be your S3 bucket, your EC2 instance. So the origin is where you are storing whatever content that you are serving. So for example, if it's a video streaming or a music streaming company, it's likely that this objects we are talking about would be stored inside of S3. So the edge location goes to, so S3 is global, but then you would need to specify a region when you're creating S3, when you're creating a bucket. So the edge location would go to that region, since that is the origin, that's the bucket that has your files, and it's going to retrieve whatever video or whatever music the user is looking for. And as soon as the first byte of it, so the response from the origin, as soon as the first byte of it hits the edge location, immediately the content starts to be served to the end user. Now, after the content has been set to the end user, the edge location also makes sure to keep a copy or cache that content at the edge location, so that in the near future, if anybody else should request for that content, it would be able to serve them that content quickly. And another infrastructure tool that we looked at is the regional edge caches. So they are less than the edge locations, and their purpose is to cache infrequently accessed data, or infrequently accessed content. So an example is having an Instagram post. So let's say a celebrity has made an Instagram post. When the post is made originally, there's going to be a lot of buzz about it. People are going to be talking about it, asking for it, etc. So in that case, it's going to be cached at the edge location. But if after a while, the popularity or the demand for that content dies down, then it would be moved to the regional edge cache. So the regional edge cache is where it's going to be in the meantime until anyone needs it again. So the idea is that the content still doesn't leave these networking data centers, so it doesn't leave and go back to the origin, but whenever the edge location should need it again, it would be at a regional edge cache nearby, and it will be able to serve the clients that's content. So thank you, Ruben, for giving us that great submission on CloudFront. So I think there's one more topic that we looked at yesterday that nobody has mentioned yet. Hi, Dennis.
Yeah. Would that be Route 53?
Yes, please.
Okay, so we also looked at Route 53, and I learned that it is the DNS service on AWS, which you can use to register domain names or transfer domain names. I also learned that it's not region bound like load balancers. And we also looked at some routing policies that are found under Route 53. We saw simple routing, weighted routing, latency routing, failover, geolocation, geoproximity, and what's the last one? IP-based routing. Yes, so that's what I know.
All right. Thank you, Dennis. So yeah, we looked at Route 53, AWS's DNS service, and we saw that the way load balancers are restricted to a region, Route 53 would help you to direct your users to your resources in multiple regions. And we looked at
Clickable.
some we looked at some routing policies, simple, weighted, latency based, where you want to, so latency based is where you want to route your users' request to the region that is going to give them the fastest response. So depending on what's need or what problem you're trying to solve, you would use one routing policy or another. And we also went into the console to create a record, but the domain name was not, it was not mine. So I could not have done that. It shouldn't be that easy for you to route a domain name to, should I say it shouldn't be that easy? Well, you need the necessary authorization for you to route a domain name to a value or to an endpoint. Because if not, then I think people would just be routing people's domain names to the endpoints that they want. So yesterday we just had an issue of me not being the owner of the domain name, so I was unable to route it to my EC2 instance. But then the idea that we got from that is you will be able to route your domain name to a resource in or out of AWS. So it could be your S3 bucket, it could be your EC2 instance, your load balancer, and you'd be able to configure that by creating a hosted zone and then creating a record inside of that hosted zone to so that whenever your users request for that domain name, they will be routed to some IP address or to some endpoints of your resource. Okay, so I think those are the topics that we looked at yesterday. So we did, we spoke about APIs yesterday, and today we are going to be looking at API gateway. So share my screen. So you've mentioned that APIs are a way for us to retrieve some function or some information from an application or a server. So inside of AWS, the Amazon API Gateway is the service that AWS has provided for you to be able to create your APIs and also manage them. So that is the service that we would be looking at today. I think it's big enough. Okay. So Amazon API Gateway takes care of the operations that are involved in accepting and processing concurrent API calls at scale. So your users making requests to your resources no matter the number of requests that they are making, API Gateway is one of those serverless offerings in AWS that help you to be able to manage these requests that they are making. So traffic management, authorization and access control, monitoring, and API version management. Traffic management has to do with the number of calls, especially concurrent calls that are being made. When we talk about API calls, it's just requests that end users are making to access your resources. And authorization and access control, it would be able to make sure that whoever or whatever resource is making that request is authorized to access that request. And then it would then grant or not grant access to the person requesting or to the client requesting. And you're also able to monitor the API calls coming in. And then it also provides API version management where you could define another version or a different copy of an API that you previously had. So before this API call, when this call is made, it goes to retrieve some, like a particular resource inside of your account. By this time, it's retrieving another resource. So that is what the versioning is about. When you edit things about the APIs that you have, and then you just give a version to them. So the first version, second version, so that whenever you need to roll back, Amazon API Gateway would always have that history for you, and you would be able to get that done. So API Gateway works with Lambda so that you are able to create serverless APIs. And the method is that you firstly create a REST API with API Gateway, and then your application can use the API to call publicly available AWS services through the code that you run in Lambda. So your end users or people using your application would be able to get AWS services to do something for them through your code that you run on Lambda. So yesterday I mentioned or we saw Amazon recognition. So the person who takes those pictures and then uploads to the application. So the person doesn't upload to the buckets, but the person was uploading to the application, if you remember. So that person does not need an AWS account for what they had to do. Thanks to the API Gateway, or thanks to the API, they will be able to have, they'll be able to get AWS to do something for them. So in this case, the person uploaded the picture to the application, and then the application had been programmed in a way that that picture is going to be uploaded to an SD bucket, and Amazon recognition would run an analysis on the picture, and then it's going to label the image. So this person has been able to use S3, Lambda recognition without the person even having an AWS account, because the person used the API to call these publicly available AWS services by the help of Lambda, because that's how the developer has configured the app to be like. So with API Gateway, you are able to create the RESTful resource-based APIs, and then you can use the data transformation capabilities to generate the requests in the language that your target service expects. So the target service, if for instance, it's If, for instance, it's a database that is your target service or that is inside of your back end, whenever the user makes a request to retrieve something, what would be run in the background might be probably a select command or a delete command. So that's how the application has been programmed. So when the person taps on this button inside of their app, it goes to retrieve them that service, because in the back end, the system that's in the back end has been configured to run on some language that's the system understands. So it's the developer that is going to make that interpretation. That's if in the front end this button is clicked, or if in the front end this is requested, then in the back end this command in this particular language should run and then give the user some result. So some benefits of API Gateway. It helps you have efficient API development. So you are able to quickly test and develop and release new versions of your APIs. And it also offers performance at scale. You are able to serve your users the lowest latency when they make requests. So their requests are handled quickly, and then a response is given back to them as soon as possible. And this is because API Gateway makes use of edge locations. So we know about edge locations that CloudFront uses. So API Gateway is also one of those services that use these edge locations. So they're able to get responses to your end users' requests quickly. And it also offers cost savings, just like a lot of the services inside of AWS. The more API usage or the more APIs you're using and managing, then the lower your pricing. So you are able to decrease your costs by using more APIs, and you're also able to monitor the performance of the API calls. So you'll be able to tell if this API call always results or usually results in a fail. You'll be able to tell how much time it takes the server or it takes the API to retrieve or to respond to your end user. All those things, you'll be able to have metrics and information on those, so that you are able to get some insights into how your various APIs are performing or how your clients are using and responding to those APIs. There are also flexible security controls. You can authorize the access to your APIs by the use of IAM and Amazon Cognito. We know about IAM. Amazon Cognito, we can think of Amazon Cognito as AWS service that provides authentication functionality. So with the way sometimes when you want to sign in or you want to sign up to I don't want to use Facebook and Google. So let's say you want to sign up to an application or sign up for a software. When you go to their sign up or their sign in page, you see some options that you can use your Facebook account, you can use your Google account. So the accounts that you have with another identity provider. So the identity provider could be Facebook, Google, it could be Microsoft Active Directory. So these identity providers, the accounts that you have with them, you would be able to use that account to access another service or another provider that you don't have an account with them, because those that you have an account with, they can vouch for you that they know this person, so allow this person to access and function inside of your service or inside of your application. So that's what Amazon Cognito does. Amazon Cognito is used for user authentication, and it manages signing in and signing up when it comes to identity providers. So these user identity providers, it is able to use them to authenticate various users that are trying to use your app. So you can integrate Cognito and IAM into your API gateway service, or when you are building your APIs, so that your end users have a proper way of being authenticated or authorized whenever they are trying to make requests to your application or to your server. And it also provides RESTful API options. You will be able to use HTTP APIs to build your APIs for a lot of use cases. So the architecture for API gateway, this is a typical example of API gateway being used inside of AWS. Inside of AWS. So this diagram shows how the client's application is able to gain programmatic access to AWS services or a particular website through one or more APIs. So these APIs are made accessible through API Gateway. So thanks to API Gateway, these three APIs, so this application one is able to make some requests to your DynamoDB table, and some response is going to be served to the user. So it's going to the user sends the request, and then the response is going to go back to the app for the user to get whatever response that they were looking for. You can also use it to query or to trigger a Lambda function. You can use it to access your EC2 instance, your VPC, etc. So this is the front end, this is the back end, and then that's the API gateway that is connecting both ends. So the front end is where the client is going to make whatever request it is, and then the API would go and retrieve the response from the back end. So inside of the back end, we know that it would be having all those responses that the user might be needing. So this is how API Gateway is used. So the connected users, mobile applications, Internet of Things devices, private applications in a VPC or on-premise. So all of these are representation of the front end or of the end that is making requests. And then through API Gateway, the requests are able to get served, and then they get some response back. And you can use Amazon CloudWatch to help you get insights into how your APIs are doing. And the API Gateway cache too would be storing frequently requested responses, so that it's not always that the API has to go to the back end to retrieve, has to go to these services to retrieve whatever response that the client is looking for. And APIs are not only limited to just AWS services. You can also build APIs and API gateway to retrieve resource from your on-premise infrastructure. And even if it's a private application in your VPC, API gateway can be used to retrieve those resources. Okay, so this is an example of a serverless web application. Here is the client. This is the S3 bucket. We see Cognito, we see API gateway. So every service on this slide is serverless. So if we remember when we were creating our static websites in the first week, I believe last week too, you created a static website again. We did not have to provision any service. We just had to upload our website code, the HTML, which takes care of the text that we see on the web page, the CSS, which takes care of the style, JavaScript, any images for your web page, etc. So you uploaded those to your bucket, and then you configured static website hosting on your bucket settings. So yeah, the S3 websites is how your user is going to get access to your web app. So that's the page that they come and meet when they are looking for your service or your application. And there's also Cognito, which provides user management and authentication functions to secure the backend API. So Cognito is there to make sure that anybody who is trying to access some resources inside of the backend, they are the authorized people to access those resources. So after the user has been confirmed, then the browser runs JavaScript and it sends the data received by communicating with API gateway through REST web services. Then the data is sent through API gateway to the backend that was built with Lambda. And in this architecture, we also have DynamoDB, which provides persistence for the application. So with DynamoDB, we know you'll be able to keep some information inside of your application. So the Lambda function that the API uses can store data in the DynamoDB database. So dependent on what call that the person is making, data might need to be stored, data might need to be retrieved. So that's why DynamoDB is present in this architecture, so that it can take care of the persistence when it comes to these calls that your clients are making to your database, to your application. Ruben.
Yeah, madam. Please, may I know the difference between the Amazon Cognito and IAM?
Okay. Cognito provides user authentication and authorization services. So when you are trying to sign up or sign into an application, so let's say this application is an application that, let's say, takes tracks expenses, okay, and the name of the application is probably Ruben Expenses. Now, before anybody can be able to use Ruben Expenses, the person might need to create an account. So when the person is creating the account, Amazon Cognito gives it works with identity providers like Google, Facebook, Microsoft Active Directory. So Amazon Cognito would be able to provide a user account to that user. So with Amazon Cognito, it doesn't matter if your user has an AWS account or not. But with IAM, it matters because IAM is the security service inside of AWS. So before anybody can have an IAM account or an IAM user account, the person should have an AWS account, and then with that AWS account, you'd create an IAM user for them.
Okay.
Is
Yeah.
that okay?
Yes, please. Thank you.
You're welcome.
And please, second, the API and the Amazon API gateway. The name, I think the gateway and the API, yesterday we learned about the API itself. So is it the general API and the Amazon API gateway is for Amazon services?
Yes, it's the general API that we know. So
From
inside
yesterday.
of, yes, from yesterday. So inside AWS, the service that will help you to write those general APIs that we know and also manage them is the API gateway.
All right. Okay. Thank you very much.
You're welcome, Ruben. Okay, so please, what is API gateway used for?
Oh, many. Okay.
Nana Chuman. Okay, Perez.
API gateways are used to create and then maintain APIs.
All right, thank you, Perez.
Okay.
Which types of applications use APIs and API gateway?
Yeah.
Yakubu.
EC2 instances.
Okay, so the resources that are retrieved, yes, they could be retrieved from an EC2 instance. Okay, thank you, Yakubu. Derek.
IoT, that's Internet of Things.
Okay,
Yes, yeah.
thank you. Ruben.
Lambda.
Okay, you can integrate Lambda 2 with API gateway. So the types of applications are web applications, mobile applications, Internet of Things. So they are the types of applications that use APIs and API gateway, and you can integrate API gateway with your static websites that you're hosting on S3. You can integrate it to retrieve functionality from your EC2 instance. You can integrate it with Cognito, CloudWatch. So there are a number of AWS services that you can integrate your API gateway service with. But these are some examples of applications. So these are how your users are going to access the API. So are going to make the API calls. You would design the applications and then they come to use them and then they are able to make the calls. Okay. So what is the difference between the API front end and the API back end? Let me see who I'm calling for this. Is John in here? Okay, William. Hi, William.
Yeah, hi, hello.
Hello.
I think with API backends, that's in development with API backend, that's when developers make the API, but the front-end API is knowing how to use the API.
Okay. Thank you. So yeah, so the front end is where your end users would make their requests, and then the back end is where the AWS services or your system is going to have a response to give to those users. So the applications then use front end to make requests. So for example, with Ruben's expense app, for instance, that application is the front end. So that's graphical user interface that his users would open and then see to look for a function. That is their front end. And then the back end is where the actual work happens, where the implementation and the communication with services happens. Okay. Let me see if try to get I'm seeing if there's a demo for API Gateway here. Lambda, DynamoDB. Okay. 10 minutes. Okay, so let's watch this demo on API Gateway.
So let's open it. API Gateway, and we are in the API Gateway console. So as you can see in here, I have option of choosing an API type. So we have HTTP APIs, we have WebSocket API, REST API, which are public or private. And so as such, we will only deal with a REST API for now. So we can try out the new console by clicking on this, and this is going to be the default very soon. So please make sure to have that, and then you choose REST API, and then you build it. So when you build an API, a REST API, you have several options. You can create a new API, you can import one from an open API definition file. So where it's a file and just import and the API is created for you. You can clone an existing API, or you can start from the example API. For us, we were going to start from a new API, and the name is going to be my first API. Now, as you see, for the API endpoint type, we have three options. We have regional, edge optimized, or private. So regional is going to be deployed in one region. Edge optimized is going to be deployed in many different regions, but it's at the edge that is going to be deployed, and then the API will still live in one region. Or private is just private, not exposed to the web. To keep things simple right now, I'm going to choose regional API type. So let me create the API, and here we are. So now we're here, we're going to create our first method in this API. So for this, you click on create method here, and then we choose a method type. So it could be any of these HTTP verbs, but we're going to do a get, just to get a page. And then you have to choose the integration type. So as you can see, we have 5 options. We have Lambda function, HTTP, mock, AWS service, and VPC link. And the one we'll be testing is Lambda function, but I want to show you that we can also integrate with any service in any region. So we choose a region, and then we choose a service. And what it does is that you can expose some of your AWS services as an API through API Gateway. So we're going to keep things simple and use Lambda functions in this one. And so we need to choose a Lambda function, but for this, of course, we need to create it. So let's go in Lambda and create our function that is going to react to this API Gateway. So we create a function, and I call this one API Gateway root get. And this is perfect. And then the framework I'll use, the runtime is going to be Python 3.11, but whatever Python 3 or Python should work. So this is perfect. Let's go and create this function. And while this is creating, I want to show you the code we're going to use. So I am in my code in my folder, and there's lambda code.py, and this is the entire code we're going to copy to lambda. And so the idea is that this is a very simple lambda function which responds to an event with some context and says, hey, the body is going to be hello from lambda. It's going to be returned as the body. The status code is 200. And then the headers is content type application JSON to let our web browser know that we get back a JSON response. So I'm going to copy this entire code, scroll down, and paste it here. So we're going to deploy this function. So I'm going to click on deploy to deploy this function. And we can also test it. So for example, I can create a test event called demo test. And then we just send this event, we save it, and then we click on test. And as you can see, the result is hello from lambda with status code 200. So everything is working fine right now, and this is perfect. And what I'm going to do now is to integrate this lambda function to my API gateway. So back in here, I'm going to copy the function ARN, go to my API gateway, and then just click and paste the ARN. Perfect. So now we have the lambda function integrated. And because we want to see the full requests being passed to lambda and being sent back from lambda, you're going to tick lambda proxy integration. Now for timeout, as you can see, even though a lambda function can have a long timeout, for example, 5 minutes or 15 minutes, API gateway has a limited timeout, and the default is 29 seconds. You can customize it and have it less than 29 seconds, but the default timeout is 29 seconds, regardless of how long your lambda function takes to execute. So let's create this method, and this is going to automatically grant API gateway the right to invoke our lambda function. So if I go back here and refresh this page, as you can see now, our API gateway can invoke our lambda function, and we can verify this by going into the configuration and then permissions. And if we have a look at the resource-based policy statement, this one, and we click on view policy, it turns out that my API gateway is allowed to invoke my lambda function if the source API is the one from my API gateway being root get. So this is the stuff that happens behind the scenes on AWS to allow the API gateway to invoke our lambda function. So we know that everything is done from a security perspective. So now we can have a look at our API gateway. So the client for this one method sends a request, and we can have a look at the request itself here. So all the settings are here. It's done integration with Lambda, and so it's a Lambda type of integration with proxy enabled. Then the Lambda itself is this function. We can click on it and get back to our function. Then the response is proxy integration. That means that the API gateway will parse what is being sent by the Lambda and interpret it. And then the method response is what we have here. We could modify it if you wanted to, but we're looking for application JSON. So let's test out this API. So for this, on the bottom right, there is a test, and you can specify some query strings or some headers, but we don't specify anything. Let's click on test, and the test is, hey, the response body is hello from Lambda. So as you can see from the API gateway, the status is 200. That comes right from our code right here, which says status is 200. We also have the response body, hello from Lambda, again, was defined in our code right here. Body equals JSON.dumps and then hello from Lambda. And finally, the content type is JSON, and that is retrieved as part of the response headers being content type JSON. On top of it, from the test, we can have a look at the execution log from the API gateway, which is really nice, which is also when you want to debug and see what's happening, a very nice way of doing so. So we have done our first execution of an API gateway on top of a Lambda function. So now let's actually debug this and see what is being sent to our Lambda function. So I'm going to do print event, and then I'm going to deploy this. And we are going to invoke now our Lambda function again from our API gateway. So we're going to run a new test, which still says hello from Lambda, but this time we are printing the events. So if we go to the CloudWatch logs, we should be able to find it. So let's go into monitoring and then look at CloudWatch logs. We're going to find the latest log stream, this one. And here we have our log, and we can see here that this was the printed event that was received from API gateway. So some information you have in here, for example, the resource, which is slash, the path slash, the method, which is get, and then you get headers, and then you get query string parameters and so on. So a lot of information is passed on by the API gateway to our Lambda function, and our Lambda function can use this information to forge a response and send it back to the API gateway. So now we can go ahead and actually create a new resource. So this time we're going to have the resource path being this, and the resource name is going to be houses. So let's create this resource. And now we have the slash houses path that I just opened. And in slash houses, I'm going to create a method. It's going to be a get again for a Lambda function of proxy integration. And I need to create my Lambda function. So let's do this quickly. I'm going to copy this and then create a function. And it's not root get, it's houses get now. The runtime is still going to be Python. And let's create this function. Yet again, I'm going to just copy this code. And so instead of hello from Lambda, we're going to change the message to be hello from and then something with houses. So my function is now created. We're going to copy this, and it's going to be hello from my pretty house. Okay, we're going to deploy this. So now we have deployed the function. I'm going to copy the function ARN and paste it in here and create this method. And so now we have slash houses that has the get method. I can test this. So let's test it and click on tests. And as you can see, I get a 200 hello from my pretty house. And so far it's pretty cool. We have the root get and we have the houses get which invoke two different Lambda functions, but we want to be able to access this from a web browser, not just testing it from the API gateway UI. So let's click on deploy API. And we need to select a stage. So it's going to be a new stage. And the name is dev. We'll have a look at it later. Let's deploy this. And now that we've deployed this API, there's an invoke URL. So I'm going to copy this URL, and then I'm going to paste it in my web browser. And as you can see, when I go to /dev, it says hello from Lambda. So this is just Firefox doing a pretty print, but you get hello from Lambda. And if I go to /houses, then I get hello from my pretty house. So this API has two Lambda functions replying to me. And if I do something wrong, if I do /wrong, then I'm getting an error message such as message missing authentication token. So here we go. We have deployed our API to API gateway. And this is pretty cool because, well, we have two Lambda functions behind the scenes actually replying to it. And that's it for our basic tutorial on API gateway. I hope you liked it, and I will see you in the next lecture.
Hello.
Yeah, well, yeah.
Hi.
Okay. Please, are there any questions before on API gateway?
Yes, Akosia. Good morning.
Good
And please,
morning.
in the video, I think there is one place that I missed. He was trying to creating the API itself or creating the Lambda. And then he was like, he has three options to make I've forgotten whatever he was working on currently, but he was like, it could be in the regional, it could be private, or it could be edge something. I missed that place, so I didn't quite get the explanation he gave for the difference. I don't know if anyone captured whatever he said.
And you don't remember whether it was under API gateway or Lambda?
Yes.
But it was regional, edge.
Regional, edge something, and then
And private.
And private, yeah.
Okay, then I think it's under the API.
Edge promise.
Yeah, so I think it's about the endpoint.
Okay.
Yeah.
So whether the the resource that your user is trying to retrieve is in your private resources. When we talk about private resources, is your the resources within your VPC that don't have internet access. So these resources only have a private IP address. They don't have a public IP address. So if you need your end users to be able to access some resources inside your VPC, then that's when you choose the
Private.
yes, the private option. And the edge option would be when you're going to use resources that are globally accessible.
Okay.
So with those ones, it's for the public APIs. So when your users are trying to access resources that are open to the public. And then what's the last one?
Regional.
Yeah, and the regional APIs are for they're to be accessed within a specific AWS region.
Okay.
So your endpoints would have the name of the region inside of it. So this is when the resource they're accessing is those regional resources.
Okay.
So depending on the service that you're using, the resource might be region bound, AC bound, or global. So if you have regional resources, then that's when you use the regional API endpoints.
All right. Thank you.
You're welcome. Okay, so we're done with API gateway. So let's start with step functions. Oh, okay, I'm not sharing my screen. Dennis.
Yeah, I wanted to find out if there's a version of this video we can have access to, because I think the demo was too fast for me. Yeah,
That's how
even
my rec talks. So fast. So you
though-
Slack me. Slack me after the class then.
okay, please.
You know, I almost asked you to slow it down a bit.
Slow down the pace.
That's-
Frenchman. Yeah, so Yakubu.
Yeah, please, and before you go on, like I didn't really get the video. Like I didn't understand.
You didn't
So
understand anything.
I guess no, I knew we were trying to create. We were linking
Perhaps
the
you could
Lambda
replay
function
the
and
video.
yeah gateway, but I didn't like. I didn't understand
Well,
what he
a
was.
lot of the things in the video were quite advanced, but okay, so let me just mention the highlights of what you should have taken away from the video. You see the end, how he's able to access the resources. So he kept the resources really simple, just web pages. And these web pages, he just printed some message on that web page. So okay, my screen is being shared. So for example, if we let me go to AWS and let's have this demo from there. Okay, so let's pay attention to the address bar. So if I should click on launch instance, do we notice what happened here? Oh, I should do that again.
Yeah, please do that again.
Okay, so right now it's ending in hash home dot dot. If I click on launch instance, can we see that it has changed to launch instances?
Yes.
Yeah, that's changed. Yeah.
Okay, so right now we are trying to get AWS to give us some function, and that function is going to help us to create an EC2 instance. So the example that he used is creating the APIs by using he used HTTP APIs where you just edit the endpoints that the user is going to use. So inside of the app or the user's app, if they click on, let's say, launch instance, it's going to change something inside of their address bar, and then it would be able to show them whatever page that they're looking for. So that's the example that he used. So when let me go back to the end again. So when the user accessed the page, so inside of his example, he went to the browser and then typed out the /dev/houses, but then the developer is going to integrate it into the application that when the user taps on, let's say, houses button, is going to bring the user this /dev/houses. So the user is going to meet this page. So in this example, what is being retrieved, or the resource that is being retrieved, is a page that has this information. So this demo was actually kept really simple. What's it called? APIs can be used to perform more complex tasks, like getting something more than just some text on a page. Is that okay?
Yes, please. That's fine.
Right. AWS step functions. This is also one of the AWS serverless services. It provides serverless orchestration for modern applications. It manages a workflow by breaking it into multiple steps, adding flow logic, and tracking the inputs and outputs between the steps. So let's think of this. Those of us who have worked in a 9 to 5 before, okay, so probably we can think of it as the procurement process. Some steps have to go through before you finally get some outputs, or before you finally get some results. So with AWS step functions, you are able to define the logic of your process. So the steps or the stages that your process has to go through, the inputs that your process has to take, and then the outputs that is going to be received after that has been done. Comment. And the output of one step is the input to the next step. So in the procurement example, for instance, maybe you need something procured, you go to your manager, they have to sign off. Only after they've signed off, you'll be able to take the paper they've signed to probably finance, and then finance will also do their bits, and then from there you'll be able to get the money, and then in the end you're able to get whatever resource that you are trying to procure. So AWS Step Functions is a service that we can use for that, but in this case we'll be using it to maintain the state of our application. So your application, or the users of your application, need to go through some steps before they are able to get the function or some output. So you would define these steps inside AWS Step Function. So AWS Step Function makes it easy for you to define these steps that your users would go through to be able to get what they are looking for. And an advantage of this is that you are able to track each step that is going on inside of your application, and you're able to also make logs of the data that is being passed between the application components. So at any step, you would be able, if something should go wrong, you'd be able to tell where exactly the process failed, and then you can continue from there. So step function gives you the ability to reuse components and use different services in your application. It also coordinates existing Lambda functions and microservices into applications. And it helps to keep your application logic separated from implementation. So sometimes your end users, the function that they want to use your app for, it involves multiple Lambda functions. And it also involves using different components of your application. So let's say you have a server that is taking care of, or you have a system that is taking care of the authentication part of your app. You have another system that is taking care of, make this more specific. Okay, so let's say it's a grocery and then cooking app. So you have another part that is taking care of probably the list of groceries that they need to be able to make some dish. So if you have an architecture that is decoupled, and for each component, it has a function that it serves, Lambda and step functions would be able to help you to make it one. So at this stage, the user would be using this particular Lambda function inside your account. Then it takes them to the next stage. Then they will be using a different Lambda function inside your account, but they are still on your application, just that in the back end, these functions or these services have been decoupled so that the user can use them. So the tags are the things that are happening in the steps, the operations or the processes that are happening in each step of your application. So the tags can be run anywhere. So they can be run in instances, on containers, they can be run as Lambda functions, and they can also be run on mobile devices. So microservices are an architectural approach where software consists of small independent services that communicate over well-defined APIs. So your software, so let's say the software is your calculator app, or the software is your Snapchat. And what is happening is that in the front end, it is one app, but in the back end, the various functions of the software has been divided into separate components, because this makes it easy to manage the whole platform, and it also reduces dependencies. So if something should happen to the whole, let's say they're not in components and then they are tightly coupled, if something should go wrong, it's going to affect all other sides of it. But if they are decoupled and anything should happen to one aspect of it, then other parts will be working. So I think some time ago on Instagram, their messages function wasn't really working well, but every other thing inside of their app was working. You can log in, you can make posts, you can like posts, all those things, but they had a feature that wasn't working well. So that's an example of a decoupled application. So we see Instagram on our phones as, so we the end users, we just see the Instagram on our phones as one, but then in the back end, they've made different components that take care of the various features that the app takes care of. So that's what we mean when we are talking about microservices, breaking out your services into smaller parts. Step function keeps your application logic strictly separated from the implementation of your application. You are able to add, move, swap, and reorder steps without having to make changes to your business logic. So your business logic is the processes that the end users need to go through to be able to get the function they're coming to your app for. So you would configure step functions to match that, and they would be able to get whatever that they need without you getting involved manually. And with this process, maintenance is simplified, and you also get modularity, scalability, and reuse of code. So if there's a stage where you had to perform some calculations, or you had to have some Lambda function happen, and then there's another stage where you need to have that happen again, then it's just a matter of you reusing that code. So it's based on workflows, and another name for workflows is state machines. And inside of this workflow or state machine, there are tags. So each step of the workflow is called a state. The tags perform the work by coordinating another service or an application that you can host anywhere. So inside of your application, one of the tasks or one of the work that needs to be performed is probably a translation. Okay, so at that stage, you'd write a simple Lambda function to take care of that in the back end. So probably from the translation, then maybe something else is going to happen after a translation is made, probably some finishing touches or something else that you could not add to the main translation. So let's keep in mind that this is one app, but the functions are decoupled. So you could take apart those various functions that they need so that it will go from step to step. So these are some benefits of step functions. Some common, I think this example should have been more detailed. Okay, so every stage is called a state, and then the tasks or work that's to be performed at each state or at each stage is, that's called a task. So some benefits of step functions. It increases productivity because you're able to coordinate the various microservices and quickly create applications. It also provides you with agility. You are able to better diagnose and debug problems faster because each stage is kind of on its own. So you would be able to tell, or you'd be able to treat the stage as the full components that it is, and then you would be able to debug from there from about whatever that's happening. It also provides resilience. You would be able to manage the operations and infrastructure of service coordination, ensuring that availability is ensuring that there's high availability, and it also reduces the chance of failure. And it supports automatic error handling. You also don't need to manage any underlying resources. It's one of the serverless offerings from AWS. So you just define your process, and then AWS takes care of the step-by-step running of it. It's a managed serverless service, and its main features include automatic scaling, high availability, pay as you go, and it's also secure and compliant because it integrates with IAM. So you are able to use policies to restrict or to grant access to the resources that you use in your workflow. And it also has the feature where you can run Lambda functions within your VPC. So in that case, it would be using the AWS private link, and the traffic would not need to traverse the internet. So this is one of the security features in AWS that comes up when you're looking at some services. So whenever a service or a transfer that you need to use does not traverse the internet, you can just use Amazon's private network to do the transfer or to get that function. It's always preferred over when you need to use a function that's going to traverse the internet, because going over the internet increases the vulnerabilities for that transfer that you're making. But if you're using Amazon's private link, or you're just making an internal transfer, like routing of traffic within your VPC, an example like that's like one of the most secure transfer designs that you can have. So these are some use cases for step functions. It's useful for creating end-to-end workflows to manage jobs with dependent components, and for dividing business processes into a series of steps. So the first example is data processing. You can use step functions to produce reports by gathering data from multiple databases and validating, processing, and normalizing the data. So inside of your step functions, your first task would be to retrieve the data from a database or even multiple databases. Then your second task, so inside of the first task, you're going to write some code, and then you would use Lambda to run this code to retrieve data from the databases. So what you can use as a trigger could be a time. So let's say your company closes work at 5 p.m. So when it's 6 p.m., then 6 p.m. is going to be your trigger for your Lambda function. And then the first task is that it is going to retrieve the data from the various databases. That's task 1. Then another task will be the data validation. So making sure that the data is clean, those things. So you write another Lambda code for that for your second task. Then you move on to your third task, processing the data. So probably there are some analytics or something that you need to run on that data. So you write that code inside of your third task. You're not only restricted to Lambda, it actually integrates well with other AWS services. So you could have that third stage of processing data. You could use another AWS service like Athena or any other AWS analytics service. So now we'll take care of the third task, and then normalizing the data to would also be another task. Then probably for the final task, you would dump, or you would load the processed data or the information into probably an SD bucket for storage. So all those steps, you use step functions to define them. Another use case when it comes to data is refining and reducing large data sets into useful formats. So as long as you have a Lambda code, or you have a function that can serve that purpose, you would be able to put it into Lambda, integrate with step functions, and then it will be able to serve those functions that you need. So you can also use for IT automation. You can use for e-commerce. So in e-commerce, you'd use it for critical business processes, such as order fulfillment, inventory tracking, etc. So your shopping app, let's think of Jumia. So the first stage of it is order fulfillment and inventory tracking. So the first stage of it would be when the order is confirmed by the user. So what happens after that? They would need to probably prepare an invoice. They would need to update the inventory to do -1 of, or minus any number of whatever the user is shopping for. You can also use it for web applications. You can combine those Lambda functions to build web-based application with a human approval. You can use it to implement a robust user registration process and sign-on authentication. So this is an example of step functions in use. This is the whole workflow, and this is where it starts. And these two states, or these two stages, they happen at the same time. So it's two parallel states. So the first one is a check name function, and it is run in Lambda. And then the another state too is check address function, also run in Lambda. So after these two states have been completed successfully, and then the flow goes on to the next state, which is open new account, and then the process ends. So in this case, the business logic is, or the function of this is a bank account being created for someone, and then they need to validate the new customer's name and address before they can go ahead and open the accounts for them. So the workflow begins with two Lambda functions, which check the name and then they check the address. So this Lambda function probably could just be running the person's name against a database somewhere, just to make sure that the person is who they say they are, and then validating the address too. That's also a function that just runs it against some database somewhere. So when these two states are successful, and then the person goes ahead to open their account, and you can use predefined system errors to handle custom errors thrown by these Lambda functions in your workflow. Because the workflow code takes on error handling, the Lambda functions can focus on business logic and have less code. What are the features of step functions? Auto scaling, high availability, you pay as you use, and it's also secure and compliant. Some benefits include productivity, agility, and resilience. And the state machine is the workflow. So that's like the whole picture from start to end. And then the states are the various stages which the flow is at. So in this example that we saw, this is the first state, and then this is the second state. So this first state has two functions because it's a parallel state. Both these things need to happen at the same time. And then the tasks are the jobs that have to go on inside of the various states. So in this case, the task here is check name, the task here is check address, the task here is open new accounts. Please, is that okay?
Yes, please.
Yes,
Yes.
Professor.
Yes.
Okay. Are there any questions on step functions?
Yeah. So from my understanding, I'm looking at it. It looks like it's the same as transactions under database. Is it like?
Well, yeah, you could think of it as something like that, because the transactions also go through some series of stages before they can be considered successful or not.
Yeah. Okay.
Akosia, but
Yes.
I feel like they are working out transactions and these step functions are working around, let me say, the same logic or similar logic, but they're not really the same. That's what I think. Because I think I came across reading the additional notes they have in the slide. There is a place that I read that with the step functions, you can, I mean, rearrange the steps, or even when the steps
Yeah, you
get
can reorder them.
adapted, you can reorder them. But with transactions,
They
they
need to
don't
follow a strict,
look like,
yeah.
yes, they don't look like the far one can happen before this one can
Yeah,
happen.
that's
Kind of,
true.
they have to follow. Yeah.
Yeah, so
So
step functions
that's
has
the
more
difference I got.
flexibility.
Okay. Thank you.
Thank you, Gifty.
Welcome.
Okay, so let's talk about containers on AWS. So containers came into existence as a result of a problem that was being faced by developers a long while ago. And the issue was that whenever they need to transport or they need to transfer an application, because they built the application inside of a particular environment, after they've made the transfer, the new location that the application is going to, it would not be able to run successfully because the application has some dependencies or has some configurations it needs that stem from or that are dependent on that old environment that they were built in. So that's when the issue of or the solution of containers was made, so that when applications are being transported, they just make sure that all the dependencies that the application needs to run, the yes, all the dependencies that the application needs to run in the new environment, the application would still have it. So instead of just transporting just the application code or the workload, you would include every other thing that the application needs to run, and then you make the transfer to the new or the other location that you want it transferred to. So migrating the workload generally meant that they would need to rebuild the application entirely, which defeats the whole purpose of transfer, because right now they needed to, previously they needed to rebuild their application because the application didn't come with everything that it's needed to be able to be compatible with a new environment. So a container is just an application with its dependencies, and it can be run in a resource isolated processes. So when you take it away from the environments that it was built in, it would still be able to run because everything that application needs to run has been put into the container with the application. Is that okay?
Yes.
Yes, please.
Okay. So the capabilities of containers can sound similar to virtual machines, but the difference is in the details. Virtual machines are isolated and they do not share the same operating system. So we've seen how we can have one machine, but thanks to the hypervisor, we'll be able to have Mac, we'll be able to have Linux, can be able to have a Windows OS on the same machine. And this is the function that virtual machines provide for us. So VMs do not share the same operating systems, thus do not also share the same bins and libraries. So bins and libraries are the commands inside of the bin. When we're looking at Linux, I think we saw those things. So VMs do not share those things, but containers they are also isolated, but then containers do share an operating system, and where appropriate, they share bins and libraries. So the bins are the binaries, which are the executable files that are compiled from source code. And then the libraries are just pre-written code that programs can use to perform common tasks. So the tasks and then the ways that the program can perform its processes, is usually dependent on the bins and libraries. So that's the main difference between VMs and containers. They are both isolated. VMs don't share the same OS and bins and libraries, but then containers do share an OS. So the main difference is the lack of a hypervisor requirements. So the hypervisor is what makes your it sections your resources. So let's say you have one PC. It's the hypervisor that's going to divide your resources so that the various virtual machines that you have on that PC would have a dedicated, or would think they have those hardware resources to themselves. Containers can run on any Linux system with appropriate kernel feature supports and the Docker daemon present. This ability makes containers portable. Your laptop, your VM, and EC2 and bare metal servers are all potential hosts of the container. And because the container does not need a hypervisor, it results in almost no noticeable performance overhead. The processes communicate directly to the kernel and are largely unaware of their container silo. Most containers boot in only a couple of seconds. So these are some benefits of containers. You are able to have environmental consistency. So it's regardless of the environment that the code was built on, because right now the code is going to be transported with its environment. So right now it doesn't really matter which environment that it goes to run on. So the code is going to keep its environment in the old and then the new setups. So you're able to have environmental consistency because the application is transported with its environment. There's also process isolation, and it is also good for operational efficiency because you're able to specify the amount of memory and disk space and CPU that a container will use when you're using it on your instance. And containers also boot quickly because they have a reduced footprint. So you're able to create and end applications that are hosted on a container. And it makes it easy for you to scale applications up and down. Containers also help your developers to be more productive because right now, instead of them focusing on the dependencies of your application, it's not them worrying about if it's going to be able to run on another environment. They can just now focus on building the application and then the application code. And it also allows for you to have multiple microservices. So it's one application, but you have smaller versions of it. No, not versions, smaller components of it, of this same application. So the developers are able to look at smaller and more manageable groups of the application. And yeah, it also offers version control. So you would be able to track versions of your application code and their dependencies. We would look at Docker right after this. So it helps you to maintain and track versions of a container. And it also helps you to inspect the differences between versions and roll back to previous versions. Docker is an application platform and it's used to create, manage, and run containers. With Docker, developers and engineers can build, test, deploy, and run containers. They include everything that your application needs to run so that your application can move between environments. So whenever you want a standardized environment, you want to reduce the conflicts between your language stacks and your versions. If you want to use containers as a service, if you want to run microservices by using standardized code deployments, and if you require, or if you have a requirement of transferring your application to another environment, that is when you would want to, also another group of developers, that's when you might want to use Docker. Docker is installed on each server that will host containers, and it provides commands that you can use to build, start, or stop containers. These are some benefits of Docker. It helps you to have the microservices architecture where it's one application, but then you would be able to divide it into smaller components. And it also provides statelessness. The Dockers are considered to be stateless because they have read-only layers. So after an image has been created, it does not change. So inside of Docker, you make images of your containers, and after they've been created, they do not change. It's also portable. So thanks to the help of Docker, your application is independent from the configurations of it, the low-level resources such as networking, storage, and OS details. So Docker helps to provide portability. For example, if your application runs in a Docker container, then it would be able to run anywhere, because when it goes there, it's just going to continue to being run on your run inside of the Docker container. It also provides us with a single immutable artifact. Docker helps with packaging of applications and dependencies. So it packages them as one artifact. And it also provides reliable deployments. Oftentimes, developers can get code running on their own machines, but it doesn't run properly when deployed to the server. And this issue happens because the server environment could be different, and that requires the developer to spend a lot of time to debug the difference and fix the issue. Developers can set up a local development environment that matches their production server. And when the developer finishes writing and testing their code, they can build it into a container and then publish it directly to the cloud. So Docker has a repo where you can publish your containers. And because it's the same Docker environment, then it would instantly work because the environment is same. So these are some components of Docker. Yakubu.
Yeah, so for the microservices architecture, is it each application, the microservice, does it run on different containers or just one container?
Different containers.
Okay. All right, thank you.
Thank you too. Okay, so these are some components of Docker. We have the Docker file, which is the blueprint or the design that is used to build a Docker image. So those details on how you want your image to, the configurations that you want your image to have, those details are going to be specified inside of the Docker file. And then you go ahead and build the image, which is the file for Docker containers during runtime. And there's also a registry, which we can think of like how we looked at GitHub repos. So inside of this registry, you would be able to store your images. So your various container files, you'd be able to store them there privately or even publicly. So people would be able to access your container. That's if it's public. So people will be able to access the images that you have inside of your repo in the Docker registry. So this registry also provides version control system for your images. So you probably have, you've built one container and then you've probably made some changes after that and then published or uploaded another. So that would be your second version of that image. Then we have the container, which is a runnable instance of the image. And then we have the host, which is the machine that runs or hosts the container. So in this case, your EC2 server, your machine, your laptop, any of those things can serve as a host. So any machine that runs or hosts your container is the host. So I think what are they called? Is it Gulf Cloud or something? So they are the owners of Docker. I don't remember their exact name. I think it's Gulf Cloud or something. So they are proprietary owners of Docker. So AWS too also has their container services that they offer. There's ECR, which is Elastic Container Registry. There is ECS, the Elastic Container Service. So for image registry, I mentioned that you can upload your images to the Docker repo, right? So the equivalent of the Docker repo inside of AWS is ECR, which is the Elastic Container Registry. And then when it comes to the management of your containers too, there is ECS and then EKS. So ECS is Elastic Container Service, and it helps you to build and deploy your containers inside AWS. So let me say it's like the Docker equivalent. Now with the Docker images, for you to have a larger scale or for you to manage and orchestrate multiple Docker containers, you would use a service called Kubernetes. So Kubernetes is also I don't know the company that owns Kubernetes, but then AWS's version of Kubernetes is Amazon EKS. So how Kubernetes solves the problem of Docker being quite limited to manage multiple containers. That's the same way that EKS to solves the problem of ECS not being able to orchestrate or handle a large amount of containers. So when it comes to hosting of your containers in the cloud, you can use a serverless compute container hosting service that is Fargate, or we can just use EC2, which we all know about. So you just keep in mind that when it's EC2, you would need to specify and provision those servers that you want to use to host your container. But with Fargate, AWS takes care of those things for you. So we're going to look at these services into more detail. So first is Amazon ECR. It's a fully managed Docker container registry that developers use to store, manage, and deploy the Docker container images. So you would be able to store the containers that you've built inside this registry. They could be public, they could be private. Anybody you need to access these containers, they will be able to go there and then download the container images from ECR. And it supports Docker Registry HTTP API version 2. You are able to use Docker CLI commands to interact with ECR. And ECR stores your container images in S3. So it benefits from the high availability and durability of Amazon S3. So we saw that S3 stores copies of your objects in at least 3 availability zones. So the chances of you losing your images is really low because ECR makes use of S3. And you're able to define and organize your repos inside ECR. And you can also set the API actions that another user can perform on your repo. So you are able to share your repo with different users and AWS accounts. ECR also integrates with IAM, and this takes care of the access control needs of your repo. So you can use policies to even define who or which exact images that users can have access to. You can also transfer your container images to and from ECS by the use of HTTPS. Your images are automatically encrypted at rest using Amazon S3 server-side encryption. ECR also supports third-party integrations. So all these container services that are not offered by AWS, you would still be able to use them because ECR supports integration with these other container services or container service providers. ECS is a container management service and it supports Docker containers. It will provision a new application. ECS will provision new application container instances and compute resources based on scaling policies and Amazon ECS configurations. Resources such as load balancers would need to be created outside of Amazon ECS. So when you are using ECS, you would need to specify if you want to use EC2 instances or you want to use Fargate. And with ECS, you can run your applications on a managed cluster of EC2 instances, and this provides scheduling. You'll be able to use third-party schedulers to perform tasks, service, and daemon scheduling. It's also one of the services that you can integrate with third-party solutions. ECS launches your containers in your own VPC, and you can use your security groups and NACLs as a security feature for this. You can also use IAM to restrict access to the service and configure which resources that a container can access. You can use ECS to launch tens of thousands of Docker containers in seconds with no additional complexity. You use a declarative JSON template, which is called a task definition. And with this template, you can specify one or more containers that are required for your task, including the Docker repo and image, the memory and CPU requirements, the shared data volumes, and any relationships that exist between containers. You can launch as many tasks as you want from a single task definition, which you register with the service. I think we can stop here for this morning. So when we come back in the afternoon, we'll continue with EKS. Are there any questions on what we've done on containers so far? Odum.
Yeah, of course, yeah, thank you. You said ECS uses a JSON, right? So I want to ask that, doesn't it support YAML?
Let me check.
Thank you.
It does support YAML. Let me check. Deploys to Amazon ECS. Yeah.
Okay.
So I just saw something in the documentation where you could use YAML to deploy to Amazon ECS.
Okay, thank you. And I also wanted to find out from the slides, you mentioned that ECS and EKS, they are the management tools. And then we have the host, which Fargate and the EC2. So my question is, does it mean we can use ECS in conjunction with Fargate?
Yes.
Okay, thank you.
You're welcome. So when you're using ECS, you choose between Fargate and EC2. Okay, so we'll continue with containers when we get back in the afternoon.
Okay, all right, thank you very much.
Okay,
Right.
thank
Bye.
you. Bye-bye.